Well, hello, Cal State's Drop. We're on the last section of notes for chapter 11. It's actually two sections combined. These last two sections were small with just a few added things about significant testing that we're going to go through, namely type 1 and type 2 errors, making sure we're ready for understanding that. You will need to have a worksheet, decision making and significant tests printed and in front of you. So if you need to go do that right now. And you'll also probably want your calculator. So make sure you have all your supplies for notes before continuing. Okay. Just a little humor to start off this lesson now that you understand what p-value is. If p is greater than 0.05, we're going to fail to reject. And so just a little fun humor. Got another one today too. Okay. All right. We're going to have to make some big decisions with our inferences, okay? And that's what we're doing. We're deciding whether we think the claim is likely or not, and if our alternative is more likely or not. This is what's done in the world all the time. Data is collected, it's compared to claims, and then they use probability to decide if that claim has any validity to it. Okay? However, there will be some times when we make a mistake. And that's because we are not 100% sure, right? We're doing a 95% sure with alpha being 0.05. There's a 5% chance we're making an incorrect decision on that one. So let's just take a look at what this is. I've got a little chart here that shows you rejecting the HO. And then what is it? Well, here, let's just start filling this in. Basically, we've done it well if we reject the HO when it's false. We did the right thing. It was truly false and we rejected it. That's what we want, right? So up here's our truth about here's the real truth about the population, and here's our decision we made. Okay, that's the correct spot, as well as this is the other correct spot we want to be, where we fail to reject HO, even when HO is true, we've done the right thing, okay? Now, the other two boxes will be where we've made our mistakes, where we reject HO, but we shouldn't have, and that is called a type 1 error. We rejected the HO, but in reality, it was true, okay? And that is our 5% error that we can make. But we could also make a second type of error, and they call it a type 2 error. So you need to keep these two straight. Type 1 is we rejected it when we shouldn't have. Type 2 error is that we failed to reject it, but it really, in reality, should have been rejected. It was false, but we just didn't have significant evidence to do that. Remember, we talked about sometimes you can get a p-value of 0.06, so there's only a 6% chance that this could have happened, which is still pretty unlikely, but we set that high standard of it. It's in order for us to really state something, we need to be below 5% or whatever percent. The problem is giving you 1% sometimes, right? So that will be our type 2 error. Okay? So I just put it in other words for us here. A type 1 error is that we reject the HO when HO is true, and that is alpha. They call that that's our alpha. Okay, that's that 5% that we where we go and we reject. However, shouldn't have. Type 2 error is when we fail to reject. Let me move myself out of the way here so you can see. Let's do this. Okay, we fail to reject HO, but HO is false. Okay, this type 2 area right here. And they've given that the Greek letter beta. I'm going to talk more about beta in a minute. This gets pretty complicated. It's easy to understand type 1 error. Type 2 error is a little harder to see how they've done the calculations. So on your decision making and significant test paper, I would like for you to copy at the very top. It says, what are the two types of errors that can be made during a significance test? I'd like for you to write down these type 1 and type 2 errors in that notes area, and then draw this little chart underneath it as an example. Okay, so take a minute to do that if you need to pause and get that done. And when you're done, come back. and fun little meme again here for type 1 and type 2 errors. So if our HO was, you are not pregnant, okay? The type 1 error is where we reject that and say the alternative, you are pregnant, and we shouldn't have, that's false. So there's the first doctor giving an incorrect diagnosis there. The type 2 error is when we do reject it, you are not pregnant. Where we accept it as likely when it should not have been. So we failed to reject, but we should have rejected it and said to that lady, yes, you are pregnant, the alternative. Okay, so it's just kind of a fun way to think of type 1 and type 2 errors. And here's a more graphical way to look at this. So the significance level alpha, okay, is our type 1 error. I just made alpha 0.05 here as an example. That's your probability of a type 1 error, okay? So you have that 95% chance here of it being, here's the truth, okay? We go around that 95%. If we come out into these tails, that's where we reject it, right? Because we get less than the 5% on a two-tailed test. And out here is where we're going to reject that, but we should not have because it was true. Okay, so alpha is the probability that the test will reject HO when HO is true. Okay? Hopefully that can be seen. Here's type 2 error, a little more complicated to understand and not being in the classroom. This whole thing of type 2 error and power, which I'm going to talk about next, are just really complicated. I'm having a feeling that you're not going to have to worry too much about it on the AP exam for you guys. I have seen it show up in the past, but I'm thinking that this time I'm hoping they stay away from this. But let's just get a grasp of it. It will be on your multiple choice questions for this test. So let's see if we can grasp a little bit of it. So beta is the letter given to that probability of your type 2 error. Remember, that's why we fail to reject the hypothesis, but the null hypothesis, but we should have because it really, in truth, is false. So here's a graph that I found trying to explain things and type things up for us. It's a little more difficult, but if you could see here, this is a graph of the actual truth. So here sits what is true, the true value, the true parameter of our population. We get a sample, or we have a claim, sorry. They say the claim is, here is your thing, okay? We run a test on that claim, and this will be, ignoring the brown for a minute, our test will be this blue graph, right, on the null hypothesis. So we will reject HO only out here in these blue tails, right? Okay. However, this area that I have shaded here for us, okay, this right here is where in our process we did not reject HO. Okay, we failed to reject HO here, even though the truth is way over here, so we should have rejected it. This is the probability right here, that area under that curve of the truth, that is beta. That's where we calculate beta. You're not going to have to calculate beta in this course. There's a big formula that runs through it. I do have videos if you certainly want to watch them. I can post them for you. Just email me and ask for them. Okay. So remember that a type 2 error is that we believe HO, okay, because we got a probability that was greater than alpha in our p-value, but we were wrong. Okay, that's that type 2 error. So power then is this probability that our fixed level of alpha that we have will lead us to reject HO when HA is the truth. Okay, that's our desired result. If HA is the truth, we want to reject HO and say HA is likely. Okay, so power is calculated as 1 minus beta. If you look back at that last chart, so if this is beta, then 1 minus beta would be the rest of this probability would be that we have correctly rejected HO. And that was, let me go back. As you can see, that's over here in this area beyond beyond the beta over here in this area, we rejected it and we should have. Okay. And that's what power is. Power is 1 minus beta, 1 minus the probability of a type 2 error. Okay. So one of the big things that AP Stats asks us to consider is how can we increase our power, because that's what we want. If power is the probability that we do what we're supposed to do, then we need that to be strong. And I have on this slide here near the end that we want that to be at least 80%. So how can we increase it? There are several ways in which it can be increased. I can increase N, okay, because now if you go to your statistic of your numerator divided by sigma divided by square root of N, well, if you know enough about fractions, when you have a complex fraction like that, you flip over the denominator and it becomes N. You're multiplying the numerator here times N, square root of N, over sigma, right? You flip that over and multiply it. So now my Z statistic is getting larger, and the larger Z gets, the further out we are, when our p-value is going to get smaller and smaller. So the smaller p-value does help us make the correct decision. We got a stronger chance of making the right decision, that because we have more evidence against it. So this, for the same reason, the decrease in sigma is now in the denominator when you flip that over in this test statistic, and sigma is now in the numerator. So when I times that by my estimate minus my hypothesized value up in the numerator, then that gives me a larger Z statistic also. So both of those ways could increase our power because we get a smaller p-value. We could also increase alpha, because if alpha increases, remember that will lower the beta. So that beta gets smaller, and then if beta is smaller, then 1 minus beta is going to get larger. Okay, this is crazy, so you might want to pause it and ponder this. But we have a greater chance of rejecting the alternative hypothesis there, but we're going to lose confidence, okay? Because we've increased alpha, our confidence level is now going down. And then, of course, the true value could be further away from our hypothesis. But again, that's very difficult to control. So whereas N is difficult because it costs money and takes time to increase it, and of course, controlling the standard deviation of the population, that's not something that's easy to do at all. So really the only one to mess around with is to try and make the best balance between your alpha. So if you want to have a higher power, that sounds good and interesting too, but a higher power level, then you would need to also increase your alpha, but then you get lower confidence in your test. So depending on the test, statisticians try to decide what is more important in that context, to have power that we've made the right decision as far as our probability goes, or how much confidence we would have that we then did make that right decision. So there's back and forth there. Okay? And we just like to see power of more than 80%. This is a very, very tricky and difficult thing to do. And like I said, trying to do this over the screen is killing me. But I can answer any questions by email. Again, I would not worry too much about power, except for that last screen that I just gave you. Kind of think through ways in which it could change. All right, so I'd like for you now to go to that worksheet that you should have your answer at the top there from before. And I want you now to go ahead and do this problem here. You've got a manager of a fast food restaurant who wants to reduce the proportion of drive-through customers who have to wait more than 2 minutes to receive their food once the order is placed. I'm sure places like Chick-fil-A, and we went through the drive-through during this COVID time, and my gosh, the line was so long, but we got through very fast. So people, the companies are working to make sure that they have satisfied customers, right? This is practical. This is very practical math here, guys. Okay, so based on their store records, the proportion of customers who had to wait at least 2 minutes was 63%. So to reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through times and test these hypotheses. So he's going to do the null hypothesis is that it's still 63%, but of course, since he's added someone to the drive-through, he's hoping that it will go less than that. Okay? And remember here, P is the true proportion of drive-through customers who have to wait more than 2 minutes after their order is placed to receive their food. We talked about this in our video conference sessions, that you need to make sure that you state your parameter very clearly. Okay, what this is asking you here to do, we're not doing the whole test right now. I just want you to list what would be a type 1 error in this setting, okay, and what would be the consequences of making that type of an error, and what would be a type 2 error in the context. And this is going to be on your test. Your chapter test is going to give you something very similar to this. And you just need to say what it is in context and what would be the consequences of making that type of error. Because this is where it comes down to. You need to decide what's more important, making a type 1 error or a type 2 error. You know, because if making a type 1 error is more important, then you want your alpha to be small. Okay? If making a type 2 error would cause more harm, then you want your beta to get to be smaller. So your type 2 error to be smaller and therefore making your power stronger. So think through this. Remember, type 1 is that you reject that it's 63, which means you accept HA as likely, okay? And it should not have happened, right? That way. The type 2 error is that you fail to reject the 63% and I think that that's still happening when HA really is likely. So those are your, put those in context, and I'm going to have you put that in Edpuzzle, and then we'll come back and look at the answers. All right, hopefully you've thought through your type 1 and type 2 errors in context. And I just have something here for you to check. Remember, type 1 is that you reject the HO when it is true. We reject HO and accept HA. So here it is in context. We think then we're doing better with the wait time because we rejected that and assumed HA, that it's less than it. But in reality, that it has not improved. So that's what's going to happen if that's our type 1 error, what we're going to believe. We will not do more things to make it better because we think it is getting better. So our consequences could be we could have unhappy customers still and continue to lose business because we think, oh, yay, what I did worked and it didn't really work. And we're not putting forth effort again to make it better. Type 2 error, now we fail to reject HO and we should. That means now that the HA is likely, I shouldn't say true there, but likely. So we think the wait time has not improved when in reality it has, okay? So we might go and take that additional employee off of the drive-through and go back to an increased wait time. Again, we're upsetting our customers and losing business. In this situation, neither of these type errors is okay. Both of them are going to lead to lost business. I would imagine in type 1 that you might eventually figure out that maybe you made the wrong decision. I don't know. The same thing might be in type 2. So some scenarios, it will be definitely clear, like in one, if life is being lost or more things are in danger, you definitely can say which one would be of deeper consequence. In this case, both of these have some pretty bad consequences for your business if those errors were made. All right. Okay. What we're going to do now is the warm-up, which I saved for after notes. And so I'm going to have you run through another scenario. Okay. It is claimed that the true mean wait time at a Starbucks drive-thru is 7.7 minutes. You're not sure if this claim is correct, and you make a random sample of 35 cars at various Starbucks, and you get a mean wait time of 8.6 minutes. So assume the standard deviation of the population for Starbucks is 2.5 minutes. If you find that mean wait time is not what they claimed, then you're going to boycott Starbucks drive-through for a year. Sorry, Abiha, she works there, and I don't know if anyone else does, but you're going to boycott Starbucks drive-through for a year. And right now, the drive-through is all we got. If you find the claim is correct, then you will go to the Starbucks drive-throughs exclusively for your coffee and nowhere else. Okay? So what it asks you to do next is at a 5% significance level, okay, is there evidence that the claim is incorrect? Okay, so you're going to run a significance test on this data first and answer this question and put that in Edpuzzle, and then we're going to come back and talk about the type 1 and type 2 errors of it. All right, hopefully you've completed that. Maybe what I need to do, though, is pull up this. There we go. Our parameter is the mean number of minutes of time that it, let's see, what is it? At Starbucks drive-through. And there's your ho and your ha that didn't give a direction. So we did a two-sided test. I found my Z statistic down here. I didn't run the conditions on this one. Hopefully you did. SRS and normal and independent. So at any rate, once you get your Z statistic, I got a positive Z. So that means I got to do 1 minus this to get that right tail, since I'm over to the right of the mean on this one. And since it's a two-tailed, I times it by 2. So we get a p-value of 0.0324. That is less than alpha at 0.05. So we're going to reject HO, and we're going to believe that the wait time at Starbucks is different than the 7.7 minutes and end up boycotting for a year. Notice all the context that I put in my conclusion. So we're boycotting now for a year. So the next part for you to think of is, what are the type 1 and type 2 errors in context of this, and what are the consequences of making those errors? So think through that and type that into Edpuzzle for me, and then we'll look at those answers. All right, hopefully you found, remembering that type 1 error means that you rejected the null hypothesis when it was actually true. Okay? So our consequence here is that we boycotted Starbucks needlessly for a year. We denied ourselves the convenience of the drive-through, whatever your consequences were that you put down. But basically, we decided to boycott, and we shouldn't have had to, because it really was still 7.7 minutes. Okay, type 2 error, though, is where we failed to reject the HO, so still believing it's 7.7, when in actuality it was false and different from that. So now our consequences are that you're going to get in line each day for coffee, anticipating your wait time to be about 7.7 minutes, but I just put you're going to be consistently disappointed with your wait time because it will be different. Okay, so obviously in this case, if I was to ask you which one you think would be worse, probably most of you would say the type 1 error, because you end up boycotting needlessly and denying yourself that. Now, I don't even drink coffee, so this is not major consequences for me. I do go to Starbucks for teas or something like that, but not for coffee. So this is no major deal for me. But for some people, this is quite a big deal. So it depends on how much into coffee you are. All right. So we just did the warm-up, the worksheet, and notes for 2 sections, and we are done. So it is now your turn to go do some homework and check your work on this, and certainly bring questions to our next video conference sessions. Remember, there's a form that you can type up your questions as well, and I can look at those before our session to make sure I cover your questions. All righty, I'll talk to you at the next video conference session, but we're done with Chapter 11 notes.